Now let's work an example of a hypothesis test for the proportion. A simple random sample of 1,000 exiting voters was taken in which voters were asked about who they had voted for in the governor's race. Of the sample, 550 reported that they voted for the Democratic candidate. Use a 0.01 significance level to test the claim that the Democratic candidate for governor will receive the majority of the votes. Okay, let's note some of the things that we know about from this word problem here. We know that our sample size is 1,000. We know that on the number of successes, how many people responded that they would vote for the Democratic, or they had voted for the Democratic candidate for governor, 550, and we're told to use an alpha, a significance level, of 0.01 to test our claim. Okay, now let's identify the original claim in the problem. Our original claim is that the proportion, where does it say that? To test the claim that the Democratic candidate for governor will receive the majority of the votes. Well, a majority means greater than 50%, right? So the claim is P, the proportion received by the Democratic candidate, is greater than 0.5, or 0.50 if you like. Do that. Okay, well, what's the competing claim then? This would cover everything else. So the original claim is P is greater than 0.50, so the competing claim will be that the proportion is less than or equal to 0.50. Now we've covered all possibilities. Okay, now we're ready to come up with our null hypothesis. The null hypothesis always contains the equal sign, so it's the proportion is 0.50 equal to, and our alternate hypothesis, this is where this work will help us. So the condition of equality is with the competing claim, so we go to the original claim to find our alternate hypothesis. Okay, so some other data we're going to find. Let me make some notes here. We're going to find the critical value. I'm just going to abbreviate that CV. We're going to find the test statistic. That's the traditional method of making the decision in a hypothesis test, is the comparison of these two on our graph. And then we'll be finding a p-value. And of course, that number will be compared to alpha, and then ultimately we'll make a decision and write a conclusion. Okay, so first let's get this critical value. Our critical value then is based on alpha, and our alpha was 0.01. So for a critical value, that means we want to find the z-score associated with the area 0.01. So maybe if I start drawing my decision diagram, we'll get a better feel for what I mean by that critical value. So we have our normal curve, and we said that our alternate hypothesis is that the proportion is greater than 0.50. So remember the little trick about that. This arrow will point to the tail involved in the test. So this is a right-tailed test. So my critical value is going to be over here on the right. And this is the region of alpha, 0.01. Okay. So now we know to find the critical value that's right here, we use inverse norm. and then we always put in area to the left. So let's see what that would be. The entire area under the curve is 1. So 1 minus 0.01 will give me that area to the left, 0.99. That's this unshaded area. All of this unshaded area. Of course, these two are complements. So I'll use inverse norm, 0.99. And let's remember how to do that. Okay, that's in our distributions second. Pull up our distributions. Okay, and inverse norm is the third one down here. Enter. Let's see. I'll get this over here. Let me do that one more time. I'm not sure we were getting all that. That's clear. Okay, second, distributions. Tab down to inverse norm. And we said we're going to put in area to the left, 0.99. And this is where we get our z-score, 2.326. So we'll round to 2 decimal places and call that 2.33. Okay, back up here, we can fill that in now, 2.33. And we can label our graph, 2.33. Of course, here's 0. Okay. The test statistic and the p-value will come from the calculator, and we'll pull that up again. We're going to do our stat tests, and this is where we'll go to the one prop z test, one proportion z test. Tab down. Enter. Now it says p sub 0. What that is the p associated with your null hypothesis. So our null hypothesis is saying 0.5 or 0.50. I think it may just truncate that though if I put it there. And then we had 550 people out of 1,000 who said they voted for the Democratic candidate for governor. Then we tab down, and now we're picking our alternate hypothesis, and what we go with is the inequality, or if it's a two-tailed test, the not equal to sign. In this case we have a greater than sign, so we'll tab over to that, enter, tab down to calculate, enter, and see here we get our test statistic. It's a z also, of course, 3.16, and a p-value. Now let's look at this p-value for just a moment. We see that it's 7.82767. Well, we know probabilities are not greater than 1, so that's the first clue that this is not just the result here. Then we see e to the negative 4. This is in scientific notation, and it's telling us to take the decimal and move it 4 places to the left. 1, 2, 3, 4. Okay, and then we'll do some rounding there. So 4 places to the left would leave us with 0.00078, and that's going to round to 0.0008. So there's our p-value. And I want to point out, oops, how did we lose that? Let's see. Here we go. This is p hat. It might be a little hard to tell that that's a little p with a hat on it, and that is the sample proportion. That's what you get if you take 550 divided by 1,000, 0.55, and then here's our sample size, 1,000. So that's a couple other little pieces of information you get here. We won't need to record those, but just to point those out. So we've got a z test statistic of 3.16 and a p-value of 0.00078, and we'll round that. Okay, so our test statistic is z equals 3.16, and I'm going to write over here that p-value 0.00078 something. We want to round to 4 decimal places, so I'm going to round that up, so my p-value is 0.0008, and I forgot to put my z over here. Okay, So these are my my critical value, my test statistic, and my p-value. So let's get these things labeled on the graph. So a test statistic of 3.16 would be out here somewhere, right? 3.16. And remember, the p-value is just this area associated with the test statistic. Okay, so clearly it's less than the area for alpha, the 0.01. And we see that it is. Alpha was 0.01, p-value is 0.0008. Okay, so now we make our decision. With the traditional method, you say, well, the test statistic falls within the critical region. We will reject the null hypothesis. With the p-value method, we say that the p-value is, if p is low, HO must go. Remember, if p is lower than alpha, so 0.0008 is lower than 0.01. So both of these agree, and our decision then is to reject the null hypothesis. But you can write all that out, or you can say reject HO. Either way, or the null hypothesis. Okay, so now we've done everything and we're ready to write our conclusion. Let's just look this over a little bit. So from our original claim and competing claim, we easily found the alternate hypothesis. We got our critical value using alpha and the inverse norm function. Our test statistic and p-value came from the one prop z-test. One, just to make a note, one prop for proportion, z-test. Remember, it was one prop z-interval for the confidence interval estimate for the proportion. So this is where we got the p-value and our test statistic. We draw a nice decision diagram here, and now we're ready to make a conclusion. And we talked about that last time, or in a couple of videos ago, about how you state your conclusion. So the first question when trying to write up your conclusion is, does the original claim contain the condition of equality? So let's go back and look. The original claim does not contain the condition of equality. It was with the competing claim. So the answer to that question is no. The next question says, well, did you reject HO? The answer to that is yes. And so that leads us to begin our conclusion with, there is sufficient evidence to support the claim that. And then we just look at the original problem. It said to test the claim that the Democratic candidate for governor will receive the majority of the votes. And we're done.